Hi, today I'm going to show you regression. So I'm going to go from this problem where you have 2 points, you can draw a line through the points, not a big deal, up to being able to solve this problem. Say you have 100 points or 1,000,000 points and you want to draw a line through them. Well, first of all, you can't draw a line through them. You could draw something crazy like that, and I'll show you how to do that later in the class and why it's a bad idea. But you can't get a nice straight line that hits all the points because the points aren't on a line. But so what we're going to do, we're going to start with our basic high school algebra way of doing this, and we're going to build up the sophistication in the next couple of lectures and end with a method that will always get a line that's close to the points. Okay. So our high school formula is y equals mx plus b. This is a line. It means that for any point x, so as we go along our x-axis here, to figure out what the point of the line is, you multiply it by m, call it the slope, and you add in this y-intercept, and you get back this value of y. The first thing we want to do is try to write the equation in terms of more than one data point. So let's just say that we have 3 points. Call them just points 1, 2, and 3. And then for each of those points, you have an x value and a y value, which you get this number as 1, 2, and 3. So now we've got to get those points into an equation somehow. Okay? So we're going to take that column numbers, take these guys, yoink them off over here. We're going to call that our vector y. Which is going to have y1, y2, and y3. Remember, all the vectors are column vectors. So what you have here on the right-hand side, first y was a scalar. Now y is a vector. That's why it has that symbol on top. And now they're written out in a column for our 3 points. Okay? Next, we'll add in the weight vector. So I got to put a hat on that so you know it's a vector. This is just going to be m and b collected in a vector, in a column vector. Now we're going to just add an x. Okay, and so we've written this. This doesn't make sense because this vector is a column, right? So it's 3 by 1, and the weights are 2 by 1. So we're going to modify this so that it looks and makes more sense like the formula. So we're going to add in a column of ones here. And now this is a 3 by 2, which I'm multiplying by 2 by 1. So that matches when we get a 3 by 1 column, which is just going to have our predictions of these y's. Yeah? All right, so we're going to call this a matrix X. This is my way of writing it bold. And so we've gone from writing y equals mx plus b to writing y equals xw. This is actually the same formula, just written out in a matrix way. You can check by doing a matrix multiplication. So say you want to see what's y1, that's the dot product between the first row and the column here. Right? So y1 is equal to x1 times m plus 1 times b. Y equals mx plus b. You've gotten the same formula back. You can write that out on your own and verify it. Okay, we'll stop there, and we'll come back to this putting points on curves business.